Last time we talked about the different types of data, and most of the time we're collecting data because we want to learn more about a certain population. And by population, I mean all of the individuals that we're interested in. Keyword here being all. Now, it doesn't have to be everybody in the entire world. The population I'm interested in may be all CRC students or all people in Sacramento. If I'm a fertilizer company making fertilizer for trees, the population I'm interested in may be all lemon trees. Now, most of the time, the population is so big that you can't collect data from everybody in the population. You don't have the time, you don't have the money, you don't have a way to get in contact with everybody in the population. So instead of getting data from everybody in the population, you'll collect data from a sample. And the sample is a smaller sub-collection of the population. So instead of asking everybody in Sacramento, you may ask a sample of 1,000 people in Sacramento. So let's say I'm interested in the percent of people in Sacramento who have a PlayStation 5. If I'm able to ask everybody in Sacramento, hey, do you have a PlayStation 5? The percent I get would be called a parameter. So a parameter is just a number like a percent or an average that you calculate from the population, from everybody in the population. Now, most of the time, like I said, you can't get data from the population, so most of the time you can't get the parameter. Now, if you calculate the percent from data that you get from a sample, that would be called a statistic. So if I take a sample of 1,000 people in Sacramento and ask them, hey, do you have a PlayStation 5? The percent I get, pretend it's 22%, that 22% would be called a statistic because it came from just 1,000 people that is in my sample, right? It didn't come from everybody in the population. Now, the central theme of statistic is my hope is that if I do things correctly, that 22%, which I got from this 1,000 people, my hope is that that 22% is a good approximation to the parameter. So my hope is that I'm able to say about 22% of people in Sacramento have a PlayStation 5, even though I got that 22% from asking just 1,000 people in my sample. That's the central theme in statistics. So today we'll talk about how do we pick the people in our sample. The first two methods I want to talk about are actually not good methods to use, and we'll get to the reason why in a second. The first method is called convenient sample, and it's exactly what it sounds like. You're going to pick the people who are most convenient or easiest to pick. So say I own a store and I want to survey my customers, all my customers. So one way I can pick a convenient sample is to pick the first 10 people who enter my store, right? That's the easiest way for me to pick 10 people. Whoever enters my store first, I'm just going to pick the first 10 people and then I'm done. If I need to do a survey, if I just contact my friends, because my friends are the easiest people for me to contact, right? That's another example of a convenient sample. If I need to measure some trees at a park, picking the 10 trees that are closest to the parking lot, right? That's a convenient sample. So what's the problem with convenient samples? Well, let me back up a bit. So remember that the theme of statistics is I'm interested in some population, right? I really want the parameter, which is the percent or the average that you would get if you were able to ask everybody in the population. But most of the time you can't do that. So you take a sample, and then you do your calculations on the sample, which means you'll get a statistic. And your hope is that your statistic is a good approximation to the parameter, which is what you really want, but you can't get. Now, the only way that's going to work is if your sample is a good representation of the population. So when you do a convenience sample, oftentimes the sample you get is not a good representation of the population. Now, for example, if I'm the store owner and I am interested in all my customers, and if I just ask the first 10 customers who come to my store, right? That might not be a good representation of all my customers because the first 10 people who enter my store are probably entering in the morning, which means I'm not getting information from customers who may enter later on in the day and may have different things to offer or different opinions to give on the survey. So convenience sample, you should try to avoid. The next sampling method is called voluntary response. And in this situation, you're setting up like a mailbox, a phone number, a website. And then people self-select to participate. So you're setting up this phone number, this mailbox, this website, and you don't get to choose who participates or not, right? The people themselves are choosing either to come to your website and participate or not. So you're not actually choosing who's in your sample. Now, the mailbox situation, what I'm thinking of here is if you go to a restaurant, sometimes they have a little comment box. Like either in the front or on your way out, where after you eat, you can choose to write down a comment and put it in the box. Phone number, example I'm thinking of here is American Idol. Which is a singing competition. So at the end of the show, they usually give you a number where you can call in and vote for your favorite act. Website, I'm thinking of any review website, like Yelp. Or Rate My Professors. Now, the problem with voluntary response samples is that studies have shown that the people who choose to participate are often the people who are either super happy or super pissed off. You rarely get people in the middle. Okay, so I have two examples of this. When I first moved out to Sacramento, I didn't know what apartment to rent, right? So I go to apartmentratings.com. If you go to apartmentratings.com, you will see that every single apartment in Sacramento sounds horrible, right? Every single apartment in Sacramento has bad reviews, which makes sense, right? The people who would choose to go to apartmentratings.com and write a review are people who are super happy or super pissed off. And in this case, it looks like it's only people who are super pissed off because I only see bad reviews. And another example, Yelp. I use Yelp. I have a Yelp account. I've written Yelp reviews. The two reviews I've written in my life have both been bad reviews because there were both situations where I was very unhappy and I vented by writing a bad review. I've never written a good review because if I'm happy, I'm not going to spend the time to write a review. So these are two methods that you should try to avoid if possible. The better methods are actually on the second page, and you'll see the methods on the second page all involve some sort of random process. So these two methods are bad and in part because both of these methods don't involve any random process. The methods on this page, which I say were better methods to use, all involve some sort of random process. And why is that important? It's important because, remember, the goal is to pick a sample that's going to be a good representation of the population. And the random process helps us because it ensures that everybody in the population has an equal chance of being picked in the sample. So that we're not inadvertently excluding anybody from having a chance of being picked. The first method, which is the simplest, is called simple random sample. In this method, we're going to use a random process. To pick a sample, and we're doing this without any prior grouping. The without prior grouping part is going to make sense when I talk about stratified and cluster, because those do involve prior grouping. So there's really only two main examples of a simple random sample. The first is the non-technology version. So to pick a simple random sample without technology, the way you do it is you take a list of the population, okay? You write everybody's name on a separate piece of paper, put the paper into a hat, shake up the hat, that's the random process, and then without looking, pick out 20 names, right? That's a simple random sample. That's the non-tech way of doing a simple random sample. Let me show you the technology way of picking a simple random sample. To pick a simple random sample, you have to start with a list of everybody in your population. Here's my list. So this is a list of fake students. You'll also see room assignment and year, but don't worry about those right now. Once you have your list of everybody in your population, to pick a simple random sample, the first thing you're going to do is number everybody. 1, 2, 3, and so on. And then we're going to use a computer random number generator to help us pick some numbers. Here it says we want to choose a simple random sample of 5 students. So what I'm going to do is I'm going to use a computer number generator to help me pick 5 random numbers, because I want 5 students, 5 random numbers between 1 and 15. And we're going to be using R for this. The command in R to pick random numbers is going to be sample, S-A-M-P-L-E, parentheses. Make sure that when you enter the command sample, it's in all lowercase. Now inside of parentheses, I want to pick 5 random numbers between 1 and 15. Now the way you're going to do that is you're going to first type in 1 colon 15. Okay, that tells R that we're going to pick random numbers between 1 and 15, comma, and then you're going to type in how many numbers you want. Okay, I want 5 students, which means I want 5 numbers, comma 5. So once again, sample in lowercase, parentheses, 1 colon 15. That means I want to pick random numbers between 1 and 15, comma 5, which means I want to pick 5 numbers. Hit enter, and those are my 5 numbers, 1, 14, 7, 12, 3. So that's telling me that my sample is going to be whoever's in position 1, which is going to be Linda. Next up is 14, which is Laura. Next up, 7, Tom. Next, 12, which is Michael. And then finally 3, which is Brandon. And that's how you pick a simple random sample using technology. The next method is called systematic sample. So in a systematic sample, the first thing you're going to do is you're going to randomly pick a starting point. And then you're going to pick every cave person. And what I mean by this is you're going to pick every 3rd person, for instance, or every 10th person. Let's now try a systematic sample using R. So here it says, choose a systematic sample of 5 students by choosing every 4th student. Okay. First thing we need to do is start with our list of everybody in our population, number everybody. Okay, we already did that because we already did the simple random sample. And the first thing we need to do is pick our starting point. And when I say pick a starting point, I mean randomly pick a starting point. And we want to use R for this. So what I want to do is randomly pick one student from this list. In other words, I want to pick one random number between 1 and 15. Okay, and the command R is going to be sample again, in all lowercase, parentheses, 1:15, so numbers between 1 and 15, comma, this time I just want one student. Okay, so comma 1. And I get 7. So I'm going to start with Tom as my first student. So starting with Tom, that's my start. And then it says I want to choose every 4th student. Okay, and then I want 5 students total. So starting with Tom, and I'm just going to count. Here's Tom, every 4th student. So 1, 2, 3, 4. That's Paige is next. Count by 4 again. 1, 2, 3, 4. Natalie is next. And then once you get to the end, you go back to the top. So I'm at Natalie, count by 4. 1, 2, 3, 4. Wyatt is next. And now I just need one more student. So count by 4 again. 1, 2, 3, 4. And that's going to be Julie. And that's how you pick a systematic sample. Now it's important that the first student, you have to use some random process to pick that first student. Because otherwise, if you don't use any random process and you're always starting with number 1, and then you do count by 5 or count by 4, right? These people, Matt, Brandon, are never going to be picked. So by choosing that first student using a random process, that ensures that everybody in the population has a chance of being picked. The last 2 methods, stratified and cluster, they both start off the same. So they both start off by breaking up the population into groups. In a stratified sample, the groups are called strata. In a cluster sample, the groups are called cluster, but that's not very important. What is important and what distinguishes them is what you do next. In a stratified sample, after you break up the population into groups, you're going to randomly pick some people from each group. Okay? An important part here is that because you're picking people from each group, you have a representative from each group in your sample. In a cluster sample, after you break up the population into groups, you're going to randomly pick some of the groups. And then use some or all of the people in the picked groups. So you're going to randomly pick some of the groups, and then you're only going to use the people in those picked groups, which means you're not going to have a representative from each group. Okay, and that's the major difference between stratified and cluster. So for a stratified sample, you're breaking up the population in groups and you're expecting the people in each group to be different, so that it's important that you have a representative from each group in your sample. So types of groups that you often see in stratified sample is you break up the groups by gender or by ethnicity, right? And you want to include people from each of those groups in your sample. In a cluster sample, you're breaking up people into groups, but you don't really expect there to be much difference between the groups, so that it's okay that you don't have representatives from each group. Let me show you a stratified and a cluster sample. Both of these methods involve breaking up the population into groups first. Let's start with the first one here, which is the stratified sample. It says group the students by year and choose a stratified sample of 6 students. So I'm telling you how I want you to break up the population by groups. And it says we want to group by year. So if I look at my population again, okay, notice that years, we have some sophomores, some freshmen, and some juniors. And I think that's it. So we have freshmen, sophomores, and juniors. So what I want to do is break up my population by freshmen, sophomore, and juniors. And I'll just go through and list Linda is a sophomore. Matt, sophomore. Okay, so I've broken up the population by freshmen, sophomore, and juniors. And now I want to pick a stratified sample. So the key point in a stratified sample is we want representatives from each group. So I want to pick some freshmen, some sophomores, and some juniors. Now it does say that I want a sample of 6 students. So I want 6 students total. It looks like there's 3 groups. So it makes sense that to get 6 students total, I'll pick 2 students from each group. Okay, and that will give me 6 students total. Now I want to pick this using a random process, as always. So what I'm going to do is, to pick my freshmen, I'm going to number them. And then I'll pick 2 students from that list. So the command in R is going to be sample, parentheses. I want numbers between 1 and 5, so 1:5, comma, I want 2 students, comma 2. And this is 2 and 3. That means I want to pick Camille and Julie. For the sophomores, I'm going to do the same thing. I'll number them 1, 2, 3, 4, 5, and then I'll pick 2 students from the sophomores. And we'll do the same thing. Sample, parentheses, 1:5, and I want to pick 2. 2 and 3 again. So I'm going to do Matt and Wyatt. And then I want to pick 2 from the juniors. So we'll do the same thing. We'll number them. And then we'll pick 2 numbers between 1 and 5 again. 3 and 1. So this is Michael and Roy. Couple things to notice. Notice that within each group, we're really doing a simple random sample within each of these groups. Okay, but more importantly, notice that in a stratified sample, I have representatives from each group. Right? I have 2 freshmen, 2 sophomores, and 2 juniors. Right? Representatives from each group. Now let's try a cluster sample. Next example here says group the students by room assignment and choose a cluster sample of 9 students. So now I'm telling you to break up the population using room assignments. As far as room assignments, looks like we have A's, E's, C's, B's, D's. Looks like A through E, sorry. So A, B, C, D, E. So instead of breaking up the students by year, I'm going to break up the students now by room. Linda is room A. Matt's room E. Okay, so I've broken up the population by room assignment, A, B, C, D, E, and now we want to pick a cluster sample. So in a cluster sample, we're going to start off by picking some of these groups. And then we're just going to use the people in those groups. Okay, so I'm going to first start by picking the groups. I have group A, B, C, D, E. I'll pick some of these groups. So what I'm going to do is I'm going to number these. 1, 2, 3, 4, 5. And I want to pick some of these groups. Now, how many groups do I need? Well, it says here that I'm looking for a total of 9 students, right? Each group has 3 students. So if I pick 2 groups, that would only give me 6 students. I'll need 3 groups. So I'll pick 3 groups and then use the students in those groups. All right, so 1, 2, 3, 4, 5. I'll pick 3 numbers between 1 and 5. The command in R is going to be sample 1:5. Okay, so I want to pick numbers between 1 and 5, and I want to pick 3 of them. And this is 1, 3, and 5. So this is telling me I want to pick groups 1, group 3, and group 5. And I'm going to use the students in those groups. So 1 is going to be Linda, Laura, or Linda, Tom, Laura. And they were in group A. 3 is Brandon, Sarah, Natalie. And they were in group 3 or group C. And then we said 5, which is Matt, Michael, Mary. And they were in group E. Okay. Notice that I picked some of the groups and then I only used the people in those groups. So I don't have representatives from each group. In particular, I don't have anybody from B and I don't have anybody from D. Okay, that's a cluster sample. Okay, which is different than a stratified sample where I do have representatives from each group. Now, when would you want to use either one? So when I broke it up into freshmen, sophomore, and juniors, I expect there to be differences in those groups, right? I expect the freshmen to be different than the sophomores, to be different than the juniors. In that situation, it's important that I have representatives from each group. So that situation is a perfect example of where you would want to pick a stratified sample. Because the groups are different, you would want to pick a stratified sample because you have representatives from each group. Now, in part D here, where I'm breaking up the students by room assignments, I don't really expect there to be differences between the groups. So students in room A and students in room B, I don't expect there to be that much difference between those students. In this case, it's okay that I don't have representatives from each group. And so in this case, I could pick a cluster sample and be okay with not having representatives from each group. Now that we know the sampling methods, here we have a list of descriptions of some samples. And what we want to do is go through and decide for each description whether it's a simple random, systematic, stratified, cluster, convenience, or voluntary response sample. So here's the tip. Simple random. There's really only 2 examples of simple random. The first is take a list of everybody in your population, number everybody, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... and then use a computer random number generator to pick your sample. The other example of a simple random sample is start with your list of everybody in your population, write everybody's name on a separate piece of paper, put the paper into a hat or a box, shake it up, that's your random process, and then randomly or without looking, pick out 20 names. Okay? Those are really the only 2 examples of simple random. Systematic is going to be easy to recognize because it should include phrases like every 3rd person or every 10th person. Stratified and cluster, let me come back to these, and let's jump to convenience and voluntary response. So convenience and voluntary response, I said were not good ones to to actually use in real life because they don't involve uh, any random process. So if the description does not mention any random process at all, it will probably be convenience or voluntary response. Convenience, remember, is you're picking the easiest people to pick. So these are things like picking the first 10 people who enter a store, the 10 trees that's closest to a parking lot, your 10 friends because that's the easiest people for you to contact. Okay, that's convenience. Voluntary response, that's where you're setting up something like a website, an email address, a physical address, a phone number, and then people choose for themselves to either participate or not participate. Okay, you're not doing anything to pick the people, right? The people pick themselves, and then you get whoever you get. Now, stratified and cluster, I think, are the hardest ones to distinguish. Both of these involve some sort of grouping. Okay, and then the question you should ask yourself is, do you have representatives from each group? If you do have representatives from each group, it's stratified. If you don't have representatives from each group, it's going to be cluster. All right, so let's try some examples. Part A. During the Canelo Alvarez versus Caleb Plant boxing match, the broadcasters invited viewers to use the hashtag Canelo Plant to tweet who they think won the fight. Right, so when I read that, I don't think I read anything that says random process at all. So I know this is going to be either convenience or voluntary response. So they are setting up a hashtag on Twitter, and then people choose to either participate or not. I would say this one is a voluntary response. Part B. Video game developers at Epic Games want to survey their player base about a new game mode in Fortnite. The developers divide the player base into groups based on the platform they are playing on: Windows, macOS, PlayStation, Xbox, Nintendo Switch, iOS, Android. They then take a simple random sample of players from each group to participate in the study. Now, just because it says simple random sample doesn't mean it's a simple random sample. So remember, I gave you 2 examples of simple random sample. This doesn't sound like one of those 2 examples. Okay, so this is not going to be simple random, even though it says simple random in the description. Now, it did say the developers divide the players into groups. Okay, groups. This is going to be either stratified or cluster. And the question you should ask yourself is, do you have representatives from each group? We're breaking up the players into groups based on the platform they're playing on. And the question is, do you have representatives from each group? If you do, it's stratified. If you don't, it's cluster. Okay, so let's see. They then take a simple random sample of players from each group to participate in the study. So they are picking players from each group. Okay, so we do have representatives from each group here, which means this is going to be stratified. Part C. City officials want to get input from people who use the bus about a possible change in schedule. They choose a simple random sample of 8 buses during a certain week and poll the riders on those buses about the change. It says simple random sample. It's probably not a simple random sample, right? That doesn't sound like those 2 examples that I gave for simple random. Okay, so this is not going to be simple random. There is the word random, so this is not going to be convenience or voluntary response. It's not systematic, right? Because systematic, I should be looking for phrases like every 3rd person, every 10th person. Which means, from a process of elimination, this is either stratified or cluster. Which means there's some sort of grouping here. What is the grouping here? Okay, we're interested in people, but then they're choosing buses, right? And then they're polling the riders on those buses. So this is an example of one common type of grouping where you're grouping people inside a bus or inside a building, right? Or inside a plane. So the groups here are the buses, okay? So people are grouped by what bus they're on. And now the question is, do you have representatives from every bus? Okay, so we're talking about a city here. They're choosing 8 buses, and then they're pulling the riders on those buses. So in a city, how many buses do you think there are in a city? A lot or little? A lot, right? So like 50 buses. So in a city, imagine there's 50 buses or 100 buses. Do you have people from each of those buses? Or do you have people from only some of those buses? Right? So you only have people from these 8 buses that they chose. So you definitely don't have people from every bus in the city. So you don't have representatives from every group. This will be a cluster. Part D. A TikTok influencer wants to give away gift cards to his followers. Starting with the list of his followers, he numbers everyone and then uses a computer random number generator to pick the 30 followers who would get the gift cards. That sounds exactly like one of the examples that I gave for simple random, where you number everybody and then you use a random number generator to pick the people. That's exactly what this is describing right here, right? He has a list of followers, he numbers everyone, and then he uses a random number generator to pick. That's simple random. Okay, and that's really the one example of simple random. The other one is the non-tech one, where you put people's name in a hat, shake it up, and then pick. Part E. A professor wants to know how his students felt about the first exam. He talks to the first 5 students that came into class that day. Doesn't have the word random anywhere, so this is definitely going to be either convenience or voluntary response. Right? Picking first 5 students. We talked about an example earlier where we're picking the 10 customers, the first 10 customers at a store. This is convenience. Part F. A computer network administrator analyzes the computer's network logs every 3rd day to check for signs of computer viruses. Okay, I see the phrase every 3rd day. Systematic. Part G. Elk Grove Unified School District has 9 high schools. School officials want to interview students about their experience with distance learning. They randomly select 10 students from each high school to participate in the interviews. I see the word random. Okay, so this is definitely going to not be convenience, not voluntary response. It's not systematic, right? Systematic, I'm looking for things like every 10th person, every 8th person. Simple random, like I said, those 2 examples I gave, those are the only ones. This is not one of them, right? So this is either stratified or cluster, which means there's some grouping here. How are people grouped here? So we're talking about students, right? We're talking about the people. And then we have these high schools. So the grouping here are the high schools. So the people are grouped by what high school they're going to. And the question you should ask yourself is, do you have a representative from each high school? Yes, you do, because they picked 10 students from each high school. So you do have representatives from each of the groups, which are the high schools. So because you do have representatives from each group, this is stratified. Part H. Raising Cane's Chicken Fingers has opened 15 restaurants in the Northern California region. The regional manager wants to interview employees about the grand opening. She randomly selects 5 restaurants and interviews the employees at those restaurants. I see the word random. Okay, this is not convenience, not voluntary response. That's definitely not one of the 2 examples that I gave for simple random. It's not systematic because I didn't see the phrase every third person or every fifth person. Once again, this is stratified or cluster. Okay, what's the grouping here? We're picking the employees. The employees are grouped by the restaurants that they work in. Okay, so that's the grouping, the restaurants. And the question is, do we have representatives from each restaurant? We don't. Okay, it says that she randomly selects 5 restaurants and interviews the employees at those restaurants. So we only have representatives from those 5 restaurants that are picked. There's 15 restaurants total, right? So we don't have representatives from those other restaurants. So because we don't have representatives from every restaurant, this is cluster. On the last page here, we have some descriptions of situations, and the question is, what type of sampling method would we use here? So example 2, a pharmaceutical company wants to test a new drug that's designed to provide superior relief from headaches. They want to select a sample of headache sufferers to try the drug. Do you think it's possible to draw a simple random sample of headache sufferers? Explain your reasoning. It's talking about simple random sample. And remember, the 2 examples of simple random sample, either you start with everybody in the population, you write each person's name on a separate sheet of paper, put it in a hat or a box, shake it up, and take it out. Okay, that was one example. The other example of a simple random was start with a list of everybody in the population, number everybody, 1, 2, 3, 4, 5, and then use a random number generator to pick your people. Now, notice that in both of those examples, you have to start with a list of everybody in the population, right? So that you can either write their name on a piece of paper or you can number them. So for simple random sample, you have to start with a list of everybody in the population. Do we have a list of everybody in the population here? Population we care about are people who suffer from headaches. Could you find a list of everybody in the population that suffers from headaches? Is there a list somewhere of everybody who suffers from a headache? Probably not, right? There's not a list anywhere. So this is probably going to be hard to do a simple random sample because we don't have a list of everybody in the population. And the population we're talking about here are the headache sufferers. So in the real world, if you were going to do this study, you actually probably have to start with a voluntary response sample. So like you'll put out an ad on TV and say, hey, if you suffer from headaches, join our study, okay? Which is like a voluntary response sample. Once you have those people, then you can start trying to do a simple random sample from that list of people. But you probably have to start with a voluntary response sample here to get your headache sufferers first. Example 3. The director of a recreation center at a university wants to sample 100 students to ask them whether they would support an increase in their recreation fees in order to expand the hours that the center is open. Do you think it's possible to draw a simple random sample of students? Okay, same question here, right? Can you do a simple random sample? And in order to do a simple random sample, remember, you have to be able to start with a list of everybody in the population. Now, example 2, we said no because we don't have a list of every individual in the population of headache sufferers. Here, what are we talking about here? We're talking about students at a university. Do you think there's a list of every student at a university? Is that a list that we can get pretty easily? This one, I would probably say yes. Because you can probably get a list of every student at a university pretty easily, right? There's a registration system. When you register, you fill out an application. Your name is in a computer database somewhere. So there's probably a list of everybody, every student at the university somewhere on a computer. So this is I would say it's a yes, because you can easily get a list of every individual in the population. And the population we're talking about here are students at this university. Okay. Once I have the list, I can number every student 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then use a random number generator to generate 100 random numbers, which will help me pick the 100 students. Example 4. A company wants to survey its employees regarding their job satisfaction. The researcher divides the employees into groups based on which department they work: sales, advertising, servicing, manufacturing. Would it be appropriate for researchers to draw a cluster sample or a stratified sample using this grouping? Okay, so we're dividing the employees by department. So the groups are sales, advertising, servicing, manufacturing. And the question is, would you pick a cluster sample or would you pick a stratified sample? So remember, what's the difference? In a stratified sample, you're going to pick some people from each group. So you do have a representative from each group. Okay, in a cluster, you're picking some of the groups and then only using the people in those groups. So really, so in the cluster sample, you don't have representatives from each group. So the question here is, in this situation, would you want representatives from each group? So we're talking about people who work in sales, people who work in advertising, people who work in servicing, and people who work in manufacturing. So do you think those groups of people are different enough that it's important to have people from each group? I'll say yeah. Yeah, I think sales, advertising, servicing, manufacturing are different enough that I think I would want some people from each of those groups. So I think I would want representatives from each group. So I would say I would want to do a stratified here because we would want representatives from each group. All right, that's it for today. Have a great day, and I'll see you in the next one.